Hello everyone, welcome to the video. Today we are going to discuss about the very basics of dynamic programming. If we are comfortable with the basics, then we can apply these concepts to any problem that can be solved using dynamic programming. So let us start right away into it, and if you are new to this channel, please don't forget to subscribe. Let's start. The origins of dynamic programming lie in a problem that we often face with recursion. What problem? The problem of duplicate problems or overlapping problems. What does it mean? It means that while solving a recursion problem, we may encounter a situation where we call the same recursion method with the same input more than once. That means we will be solving the same problem more than once, which is inefficient because solving a problem consumes processing power. Let us understand this with the help of an example. Consider a recursion problem P that takes as an input two variables I and j. Now let's say in the recursive relation it is dependent on P I comma j minus 1 and P I minus 1 comma j. Now if we try to draw out the recursive tree for this, let's say we started with P6 comma 6 just for the sake of an example. Then it will be dependent on what? P6 comma 5 and P5 comma 6. So a recursive call using this input would result in two calls with these two inputs. Now what will be the further progression of this tree? Let's see. For P6 comma 5, the first child will be I comma j minus 1, meaning 6 comma 4. Then second will be I minus 1 comma j, meaning P5 comma 5. And similarly for P5 comma 6, it will be P5 comma 5 and P4 comma 6. Do we see the problem here? The problem here is this P5 comma 5. This is coming twice. That means this same problem with the same input will be computed twice. We don't want that. We don't want to spend our computational power twice. So how do we solve it? This is a very common problem that we will encounter in recursion. We want to solve for the problem P, but as we solve for its subproblems, we encounter duplicate subproblems like the problem P3 here. Here P3 needs to be calculated twice, which is inefficient. So how do we eliminate this inefficiency? We can say that whenever we first encounter the problem P3, we should just store the answer to P3 directly somewhere. And then whenever we come to the second time and encounter P3, we should, instead of calculating again for P3, we should just find the answer of P3 and return that. Now, how do we do that? What data structure suits us best to store this? That data structure should be fast in storing the result, and it should also be fast in retrieving the result back. What is such data structure? That data structure is map. What will be the input? Map is basically a pair of key and value, right? So what will be the data type of key? The data type of key will be the data type of whatever is your input. So input type could be string, input type could be integer, input type could be anything complex, even list of lists or anything. So the data type of this map would be whatever is your input type, and similarly the data type of value will be whatever is your output type. How will we use this map in our recursive call? It is simple that in our recursive function, now in addition to the input, we will also pass the map. Then before calculating for input, we will just first see if we have already calculated for it. That means we'll check in our map if the answer for this input already exists. If it exists, we return it directly from the map and we do not calculate. And if it does not exist, we write the whole logic of calculation. And then before returning the output or before returning the result for this input, we put that in the map so that if some time later again the call for this input comes, we don't have to calculate again, but we can directly return from here. This is the most common technique that we will use to solve the recursion problems. This technique is also called memoization, and This is basically dynamic programming, that we do not calculate the results twice for the same input, but we store the results somewhere and then we get those results whenever we need or we encounter the same input again. There is also a disadvantage of using top-down dynamic programming. Top-down dynamic programming uses recursion. So the disadvantage of recursion comes here also. What is that disadvantage? In recursion, we make the call to recursive method one by one till we reach the base condition. And each method call is not resolved till the call above it is resolved. That leads to occupying a lot of space in the memory. Why? Because every method call has to occupy some space in the memory. So more deeper the recursion tree, more is the space consumed in the memory. That is why top-down dynamic programming is disadvantageous in terms of space utilization or memory utilization. Here comes the need of bottom-up dynamic programming, also known as tabulation. So how does this solve this problem? It does not use recursion at all. By avoiding recursion, the number of method calls are limited and hence the space consumed is limited. Now the question arises, if it is not using recursion, how is it solving our original problem? In recursion, what we do is we start from whatever input is given to us in the question, and then we move downwards in the recursion tree towards smaller inputs. And in the end, we will reach what is called as the leaves of recursion tree, or these will basically represent the base conditions of the recursion, where the recursion tree terminates. That is how we proceed in the top-down recursion. But in bottom-up, what we will do is we will proceed in the opposite direction. We will first calculate the values at the leaves, and then using these values, we will move upwards and keep filling the answers for these problems till we move and reach our input, our original input to the question. So we can say that in the top-down approach, we move from larger input to smaller input, while in the bottom-up approach, we move from smaller input to larger input. So how do we do that in bottom-up approach? We will still use the insight of the recursive relation. That means we will still use the answers of smaller problems to find out the answer for our bigger problem, but in a bottom-up manner. So let us say we have a recursive relation that is dependent on two variables I and j. So what we will do here is, instead of the map in the top-down dynamic programming, we will allocate a memory space in terms of, let's say, matrix. And the dimensions of matrix will be the maximum values that I and j can take. Now we will fill up this matrix row by row. Why row by row? Because consider if this element is your I comma j, then it is dependent on I comma j minus 1 and I minus 1 comma j. So before we fill the value for this element, these two should be filled. So we will probably fill this matrix row by row. And when we reach here, our bottom right corner, that means we have reached the maximum values of I and j, which will often be the input that is given to us in the question. So we will get our answer from here. This way, we were able to use the recursive relation insight, but we were able to avoid the recursion itself. Therefore, bottom-up dynamic programming approach is most of the times better than the top-down dynamic programming approach to solve the same problem. So to summarize, dynamic programming solves a situation that we can encounter in recursion. What situation? It is possible that while solving a recursion problem, we may encounter a situation where we are solving the same problem with the same inputs more than once. That will be very inefficient in terms of computational power. So dynamic programming solves it. How does it solve it? Whenever we encounter an input to the recursive method call, we basically solve for it and store its results in the map. Map's key will represent its input and its value will represent output. So we will have this information stored that, hey, for this input, this is the answer. Now, before solving for any input, we first check in the map that if we have already seen it. If we have already seen it, that means we have already solved it. So no need to solve it again. So we return directly from the map. The biggest benefit of dynamic programming is that it greatly reduces time complexity of recursion problems. However, it occupies some space in the memory, which is significant because of the multiple method calls that we make due to recursion. We solve this problem by using the bottom-up dynamic programming approach. In the bottom-up approach, we first solve for smaller inputs and gradually move towards the solution for larger inputs. This is it for this video. We will use these concepts to solve many dynamic programming problems in this channel. If this video helped you in understanding dynamic programming any better, please let us know in the comments. Also, what dynamic programming problems would you like to see on this channel? Please comment below. Please don't forget to like the video and subscribe to the channel. We will meet again in the next video with some other problem. Thanks for watching.